So this is question 7, the final list for our CS88's Fall 2020 midterm. So the directions for this question is a bit long, so I'm going to try and summarize it. So you want to implement a function called better starting position, in which you're given a board represented as a list that contains the amount of gold you can collect at each index. You're also given two starting indices that you're considering, start index 1 and start index 2. So the way it works is after you choose the starting index, you can only move towards the right of the board to collect gold at each index, and you will be collecting, or you can only collect gold at every other box, or sorry, every other index. So that means is you're going to skip one spot every time and move on to the next one. So since you're given two starting index, what you're actually going to do is you're going to do that for each index and see which starting index will give you more treasure. Your final return value should be a 2-element list, which contains the better starting index out of the two, as well as the corresponding amount of treasure you would accumulate starting from that index. Okay, and you can also assume that the input list only contains positive numbers. So we're given two doc tests. We'll just look at the first one to kind of get a better idea of how this function should work. So in the first doc test, we're given a board that contains 10, 11, 12, 13, 14, and 15. I drew it right here for better visualization. And better starting position is called on this board with 2 and 3 passed in as the indices we want to consider for starting indices. So let's actually do that. Since there's going to be some kind of comparison here, we're most likely going to have to find the path and the amount of gold that you're going to get for each starting index, and then compare it at the very end to determine which one we should be returning. So let's notate down the two options, 2 or 3, right? And then work through each of them individually, and then at the very end, compare. So going along with the rules for moving across the board, if we start at 2, we can only go right, and we have to skip the next one. So we do every other index, right? So if we're at 2, we can only go to 4. And after 4, there's a 5, but we can't go to 5 because it's the next one directly, or the one directly next to 4. And there's nothing after 5, so we're actually going to stop at 4. So let's kind of extract this out, where we have index 2 and 4 and its corresponding gold, which is 12 and 14, right? So let's do the same thing for 3. So if we start at 3, we could only go to 5, and there's nothing after 5. So the two spaces where you can get gold from is index 3 and 5. So let's pull that out so it's easier to see. 3 and 5 with corresponding gold of 13 and 15, right? So to see which one is better, we need to sum up the amount of total treasure we can accumulate from each path. So for 2, we just need to sum 12, 14, that gives us 26. For 3, we just need to sum 13 and 15, that gives us 28. Right off the bat, we can see that 26 is less than 28. So path 3 is actually going to be greater than starting from index 3 is going to be greater than starting from index 2. So remember, the final return value actually should be a 2-element list with the better starting index and its corresponding amount of treasure you would collect, right? So if 2 had been greater, it would have been 226. If 3 is greater, then it would be 328. Well, we already know that 328 is the better one, so that is what we will be returning for this function call. Okay, so let's kind of start implementing our code and look back towards this little process that we had drawn out here on the right to give us a better idea of how it should look like. Okay, all right, so we can see that one thing we need is we need to accumulate the total amount of treasure for each path, right? So we have this and this right here, right? So we need to initialize a variable in which we can store up and accumulate the gold so that we can compare at the very end. This is probably one of the most important part of the problem, since it will be determining which path or which starting index is better. So we can call the variable that keeps count of the treasure for starting index 1 as total 1, and the one for starting index 2 as total 2. Let's initialize it with 0 since we are accumulating. So we'll be adding on new amounts of treasure at each step, right? Okay, so after we have initialized total 1 and total 2 so that we can keep track of the total amount of gold, we need to do the actual part about going along the board to collect gold. So for 2 and 3, what we did was we start at the current index, right? And then we went to the next every other one, right? So we went from 2 to 4, and then we went from 3 to 5. Do you see some sort of common pattern here, right? So what we did when we were going down the board was we first started off with, let me write it here. So path, we started with the start index. So it could be start index 1 or 2. This is just a generalized version of each one. So we started with start index, and then we would go to every other one, right? So to go to the next one, notice that here, you would go from 2 to 4. That's a difference of 2, right? Same thing with 3 to 5. That's a difference of 2. So if you actually wanted to mimic the skipping the next spot and going to the every other one, that is the same thing as going through an increment of 2, right? So you would increment by 2 to skip the next one. And then what determined when we would stop moving along the board, right? So we would stop moving along the board once we hit the end of the board, right? So for 2 to 4, when we try to go to the next one, we would hit the end of the board. When we go from 3 to 5, if we try to go to the next one, we would hit the end of the board, right? So the condition that determines when we should stop going along this path is once we hit the end of the board, which we could represent with the length of the list, right? So with these characterizing how we're going to move across the board for each index, we can actually turn it into a range to iterate across the board. All right, so if we want to iterate across, let's say, starting index 1, we can start a iteration, the for loop for I in range. We know our start index is going to correspond to what is passed in for, oh, my bad, start index for 1. And we know we will stop once we hit the end of the board, which is represented by the list. So in this case, it's just going to be the length of the list. And we want to represent, or we want to mimic the every other index, and we can do that by incrementing by 2 at each step. So that allows us to go through the board the way that the directions specified, with going every other and starting from the given index and ending at the end of the board. So now that we are able to move through the board as desired, we want to make sure we actually collect the gold, right? So to collect the gold, what that means in our case in coding is we're going to accumulate it, calculate it, accumulate it in the correct variable, right? So for here, we're going to accumulate it in total 1 for starting index 1, and we get this amount of gold from the list, right? So I corresponds to the index of the list that represents the board. So if we want to actually get the amount of gold at each index, we would just index the list and then make sure we increment total 1 each time, right? So that is these 2 lines represents the action of going through the board from starting index 1 and collecting gold. So we just need to repeat the same thing for starting index 2. So I'm just going to copy and paste this really quick. Right, so you repeat the same thing for both of them because in the very end, you're going to need to compare. Index here, okay. Okay, so, and then make sure you do not confuse the 2 variables. So this one should be added to total 2, right? So now we essentially what we did is we have all of this, right? All of this coded out because we have total 1 and total 2. Now all we need to do is compare them and see which one do we return. So if starting index 1 had a total that was larger, we would return the values corresponding to the starting index 1, right? So in that case, it would be return start index 1 and make sure you return the total corresponding to 1. Right, so that's if total 1 is greater than total 2. But if the other index gives us a a larger total, we will return the values corresponding to the second path. So we start index 2, and then make sure you return total 2.